Hello children, in a previous class we discussed work energy theorem. That is a most wanted 8 marks question. If you have not watched that video, link will be given in the description. Kindly go through it so that you will get 8 marks. Fine. In today's session children, we are going to discuss one more 8 marks question. That is law of conservation of energy, and we have to prove that law of conservation of energy with a freely falling body. Dear children, before going to discuss what actually law of conservation of energy and proof, let us see the marks distribution. Children, in this question, first we have to write the statement of law of conservation of energy. For that, 1 mark will be there. And before going to do a derivation, in this question, a diagram is very important. Even diagram carries 1 mark, and the next 3 marks for verification. 1 mark for a statement, 1 mark for a diagram, 3 marks for verification. And one more mark here, very important thing is that children, we have to write the condition. Means when this law of conservation of energy is valid. For writing that condition children, 1 more mark. Again, till here total 6 marks only. What about 2 marks question children? Yes, that is numerical. So definitely there will be a numerical attached. And what are the numerical which is going to attach to that question? Today video we are going to discuss. So 100% this numerical will be asked along with this question. So 1 mark for a statement, 1 mark for a diagram, 3 marks for a proof, 1 mark for a condition, 2 marks for numerical. Total 8 marks. Okay children. Now without doing delay, let us start. What actually law of conservation of energy? Yes children, once again let us recall the word called energy. What is energy children? Can you recall? Yes. Energy is the ability to do the work. Okay, that's fine. Children, can you think or can you recall some forms of energy? Can you? Yes, recall. Let me tell you also. Of course, many types of energies are going in your mind, no doubt about it. But let me also add few things which are going in your mind. Light energy, electrical energy, mechanical energy, kinetic energy, potential energy, nuclear energy. Okay, like this units, there is a big chain system. Okay, fine. But dear children, let us think once again. Okay, these many energies which we have, are you able to produce any one of the energies? Think once. Can you produce or can you destroy any energy? No, it is highly impossible. Highly impossible. We are not producing. Then you may get one doubt. Sir, how can you say like that? Whenever I switch on the light, the bulb will be going, light is coming. Yes, that is what I am doing, right? You may think. Okay, what you are thinking is right only, but think in depth children. Are you producing that energy or are you converting? Oh, then you start thinking now. Am I right? Yes. Means what happened? Already electrical energy is there. What are you doing children? Just you are converting that into light energy. You can take a fan also. Whenever you switch on that, it will be rotating so that it does some work. Means their electrical energy is converted into mechanical energy. Like that children, we only convert energy from one form to another form. Means we cannot produce, we cannot destroy also. This is what actually law of conservation of energy says. Conservation means what children? Constant, remains same. Energy in the universe always remains same, but it can change form from one to another. Okay, so in exam when you start a question answer, first you have to write the statement. How you should write? Just look at the board children. So according to law of conservation of energy, or law of conservation of energy states that energy can neither be created nor be destroyed, but it can be transferred from one form to another form. Yes children, this is what actually you have to remember, you have to write as it is. Children, once again I repeat, according to law of conservation of energy, energy neither created nor destroyed, but it can be transferred from one form to another form. This is a statement, fine. Now we have to prove this for freely falling body. Children, now you may get wondered, sir, what is this freely falling body? It's very simple. Can you look at this marker? Yes, yes, fine. Now look at this. Now if I leave this, what will happen? This is going to be a freely falling body. Am I clear? So here take this case only, or you can take any ball also. Any ball also you can take. Am I right? So whenever it is left, Okay, and one more very important thing is that whenever it is falling, dear children, will there be any initial velocity for that? No, we are not giving, we are not throwing children, we are leaving. It's very important. So whenever you leave, so it starts with zero velocity. So it's a very important point to be noted is that actually what is children? The initial velocity of freely falling body is zero. Now we take a freely falling body and we will prove conservation of energy. Okay children, this diagram of whatever we are going to make is very important, which makes 1 mark. See children, not only 1 mark children, without the diagram we cannot prove law of conservation of energy. Okay now let us see children, let us take one body of mass m. Okay, look at here, here is a body of mass m, h plus x. Children, now look at that. Let me explain the picture, not to get confused. Okay. So, children, the body from where we are leaving, children, we are leaving such a that it is height is h. From h height, a body of mass m is left. Okay, now then it is falling freely. It is falling freely. Children, in its path, we are going to take any 3 points. One is initially the point from where the body is left. And the final point is just before going to hit the ground. Children, it's not hitting the ground, just before going to hit the ground. Okay, now. So let this point, what initial point, let us say it as a. From point A, it is left. Okay, and point C is a final point, just before going to hit the ground. And children, this point, let us say it is a B. And here one more important thing is that children, this point B may not be exactly midpoint. No, you can take anywhere. You can take anywhere. So we are going to choose the 3 points. Now at a point A, at a point B, at a point C, we have to prove same energy. The value should be same at a point A, at a point B, at a point C. Then we can say that energy remains constant. Okay children, fine. Let me explain once again. A body of mass m is left freely from a height of h. Okay children, as it is left freely, what is its initial velocity? Children, at a point A, its initial velocity will be 0. This is very important. Its initial velocity will be 0. Fine. As it is after traveling a distance x, we have chosen one more point. So, do you think that the body will have some velocity at a point B? Of course, it will have. Let its velocity will be v dash or v1, you can say that. And it is at a height h minus x from the ground. Children, it has covered x distance from the point where it is left, and after some time when it reaches at a point B, it is at a height of h minus x from the ground. Now, at a point C, just before going to hit the ground, children, it has a maximum velocity. Let velocity is v at this point. Once again I repeat children, now we are going to take a point A, we will calculate the energy. We are going to take a point B, we will calculate the energy. At a point C also, we will calculate energy, and we are going to prove the energies at point A, at a point B, at a point C, we are going to prove a same. It should be. Then only law of conservation of energy is proved actually. Okay, fine children. And before going to discuss actual children, let us recall few terms which are very important to understand to us, so that we will derive the verification very easily. What are those things? Children, first you should know what is the formula of kinetic energy. So kinetic energy is half mv square. And what is the formula of potential energy, children? Potential energy, I am talking about gravitational potential energy, that is mgh. And children, one more important thing, we all know very well about law of what we can say equation of motion. In that, this equation of motion, that is v square minus u square is equal to 2as. Children, these 3 formulas are very important. Of course, we must know, because these 3 we are going to use in order to prove law of conservation of energy. Am I clear children? Kinetic energy formula is half mv square, potential energy formula is mgh, and v square minus c square is equal to 2as. So with these 3 formulas we are going to use in order to prove the law of conservation of energy. Okay, fine. Now let us start children. First we will take a point A and we will calculate, And children, before that, what is a mechanical energy, children, actually? Yes, when there is a energy, what we can say, transaction between only potential and kinetic, we can say that the sum of the potential and kinetic energy is equal to the mechanical energy. Mechanical energy, which means what? At every point, at point A, at point B, at point C, we are going to calculate individually kinetic energy, potential energy, and that to be added in order to get a mechanical energy. So, means indirectly, what are we going to do, children? Here we will calculate mechanical energy. At a point B, we can calculate the mechanical energy. Even at a point C also, we are going to calculate mechanical energy. Now, let us see at point A. So, at a point A, we will calculate. First, we need to calculate the kinetic energy, children. So, we know that kinetic energy is equal to half mv square, But each children, at a point A, what is the velocity? Velocity is 0. So, this only, see, velocity means, let me write in terms of initial velocity, no problem. Anyhow, as the initial velocity is 0, it will be half m into 0 square. So, kinetic energy at a point A is, children, it is a 0. It is a 0. So, what about potential energy? Potential energy will be mgh. Now, look at, children, this point A is at a height of h, right? So, it will be mgh. So, this is kinetic energy will represent with the k. Potential energy will represent with the u. Children, now we got potential energy and kinetic energy, which means what, children? At the point, at the beginning, when it is about to leave, okay, about to fall, only it has a potential energy. Whatever the total energy it has, only in the form of potential energy. So, children, we know that mechanical energy E is equal to sum total of kinetic plus potential energy. Now, you can add, this will be 0 plus mgh. So, children, mechanical energy at a point A will be mgh. This is what actually we got. So, potential energy is this much, kinetic energy is this much, and the total energy, that is mechanical energy at a point A is how much, children? mgh. Here we got mgh. Now, we have to prove energy mgh at a point B also. Let us see, children. Now, we will see at point B. At point B, what mechanical energy going to be? Children, to prove that actually, okay, now let us consider from point A to point B. It's a very important. So, let me take here, let us say the point A to point B. So, children, at a point A, its initial velocity is 0, but at a point B, if you can see, its velocity will be v1, and from point A to point B, how much distance has covered? X distance. So, s is equal to x. And whenever a body is traveling under the action of gravity, A is taken as g, that too it is going downward direction. First, children, let us see a kinetic energy at a point B. So, kinetic energy at point B, how much? Half m. Does it have some velocity? Yes, it has a v1 velocity. So, it will be half m v1 square. But children, do we know the v1 value? We don't know that. So, that is an unknown quantity. So, unknown quantity must be eliminated. Eliminated means what? Just not rubbing. It's not that. So, with the calculations, we have to eliminate the V1. Means we must calculate the V1 value. Then we have to substitute in it. Then we get the kinetic energy at a point B we get. Children, for that, we are going to use V square minus U square is equal to 2AS. So, V is equal to how much? V1 square. V1 square, and U is equal to 0 square, 2, A is G, S is X. So, here V1 square is equal to how much we got? 2GX. Let this equation be 1, this equation be 2. Now, children, let us substitute equation 2 in 1. Equation 2 we are going to substitute in equation 1. Now, look at here. Kinetic energy is equal to half m. In the place of V1 square, we are going to write 2gx. 2gx. mgx. So here half cancel. So this is kinetic energy is equal to mgx. Children, just we got kinetic energy. How much does a body have kinetic energy at a point B, children? mgx. Then what we have to do? Even we have to calculate potential energy also. So potential energy at a point will be mg. Whatever height, children, we have to take from the ground. So this point from the ground is at a height of h minus x. So this will be h minus x. So let us simplify this, mgh minus mgx. This will be the potential energy at a point, what we can say, okay, at a point B. Now what we have to calculate? We have to calculate the total mechanical energy. So children, mechanical energy is equal to what? Potential energy plus kinetic energy. So potential energy is equal to how much we got? This much we got. Let us substitute here, mgh minus mgx. Whatever kinetic energy, we got mgx. So plus mgx. Children, both will get cancelled. So mechanical energy at a point B is equal to mgh. So this is the total mechanical energy at a point B. Children, at a point A, how much we got? mgh only. At a point B, how much we got? mgh only. So we have to prove even same amount of energy at a point C also. With that, this derivation is going to be concluded. Okay, children. So here I think I need a space. Just you copy it so that I can run. So we can go for that. Come on, just copy it. Fine, children. Now let us calculate at a point C. At point C. So children, how much we got mechanical energy at point A? Point A is equal to, we got mgh. At point B, how much we got? Let us write here, mgh only. Now let us see what is the energy going to be at a point C. So children, for that, let us take from where the body is falling actually, at point A to point C. At this initial velocity will be 0. So children, what is the final velocity? It has v. And one more thing, children, at point C, what will be the height from the ground to that body? Children, it's almost negligible. Just it is about to hit the ground. It is just about to hit the ground. Means what here? Height is negligible. Height is negligible. Now what is the total distance traveled? Total distance traveled is h, and A is equal to, as well, it is a g. Okay, now let us see, children. First, let us calculate the kinetic energy at a point C. Okay, children, we know that kinetic energy is equal to half mv square. But here v square, v value is not known. What we have to do? We have to apply the equation of motion. What is that here? V square minus u square is equal to 2as. Now let us apply that. This will be v square minus 0 square is equal to 2gh, of course. So it is v square is equal to 2gh. So let it be, it is a third equation, it is fourth equation, children. So let us substitute here fourth equation in third equation. So what we'll get here? Kinetic energy is equal to half m. In the place of v square, we have to write 2gh, that is 2gh. So here 2 gets cancelled. So I got kinetic energy as mgh. That is fine. This is the kinetic energy. What about potential energy, children? Potential energy is actually the mg. We have to talk about the height. Children, as I said that at a point C, it is just about to hit the ground, which means what? Height is almost 0. Minimum means we can neglect it actually. It will be 0. So potential energy at a point C will be 0. Now let us see, children. Mechanical energy is equal to potential energy plus kinetic energy. So it will be 0 plus mgh. So mechanical energy at point C is equal to mgh. So hence we got mgh. That is energy at point C also we got mgh. So children, this is what actually law of conservation of energy in the case of freely falling body, which means what? You can take in its journey at any point you can take children. The important thing is that energy always remains constant. But here just think about that. At a point A, body has energy only in the form of potential energy. At a point C, body has energy only in the form of kinetic energy. But in between point A and point C, body has some potential energy, some kinetic energy. Means at any point you can take that, the total energy remains constant. Here it might be potential energy, it might be kinetic energy. Means what is happening here? Energy conversion is taking place. Otherwise, total energy remains constant. Okay children, so just you copy this. This is what actually energy, law of conservation of energy in the case of freely falling body. Yes children, so by writing a statement 1 mark, for this diagram 1 mark, for a derivation 3 marks, total 5 marks. What about 1 more mark? Children, this is what actually condition. So, law of conservation of energy is not valid 100%. I like work energy theorem. Children, work energy theorem valid 100%. Because there we calculate the work done by all forces. I mean what? Conservative forces, non-conservative force, even external force also taken. But here it is not like that children. This is not that. Means law of conservation of energy is valid only in the absence of non-conservative forces such as air friction. Don't you think that when the body is falling freely, air will be there? Yes, obviously. To overcome that friction children, some energy is spent. So obviously here energy may not be equal to at this point energy. That's for children. So I said that one more mark is for condition. What is that one more mark children? So here neglect. We have to neglect the non-conservative forces such as air friction. By writing this condition, better you can write at the end only. At the end, after proving this, we have to write law of conservation of energy is valid only in the absence of non-conservative forces such as air friction. Okay children, so writing till here children, we get 6 marks. What about another 2 marks? Yes, that is for numericals. Now let us see that numerical. Yes children, now just look at the numerical which is going to be asked along with this law of conservation of energy. Okay na? Children, fine. So according to the question children, let us say it is a well. Let us say here is a well of depth 25 meters. 25 meters. Here water is there, let us say. Okay, from, and here is one electric motor is there. Let us say here is some electric motor. So this electric motor has to lift the water, means 600 kg water per minute. I mean what here? Mass is given here 600 kg per minute children, per minute. So here 1 minute is given, that is 1 minute it is given 60 seconds. For every 1 minute it has to lift the 600 kg of water from a depth of what? 25 meters, that is H is equal to given 25 meters. 25 meters. Not only that, it has to send the water, with a certain velocity. That is here water should come out. With what velocity they are saying? They are saying that it is a 50 meter per second. So we have to calculate. They are asked us to calculate, means it is asked to calculate the power of the electric motor. If it can lift the 600 kg of water per minute from a depth of 25 meters and it will eject the water with 50 meter per second. So children, we know that here power is equal to work by time. Children, of course here electric motor is doing work, but just observe the carefully children, it is doing work in order to lift the water, that is doing work against the gravity, and even it is sending water also. Means here from here to here it is doing one work, and in order to send the water also it is doing one more work. 2 works are there, which means what here? It is W1 plus W2, that is the total work done by the motor in a given time. So what are the work which is done in order to lift children? It is stored in the form of gravitational potential energy. But whereas what are the work done in order to send the water is stored in the form of kinetic energy. Is stored in the form of kinetic energy. Hence, we can write power formula here, sum of the potential plus kinetic energies in a given time. But potential energy means, we know that children, what is that? mgh plus kinetic energy is what? Half mv square by time. Now, let us substitute the values. Here mass can be taken as a common. Okay, you can take, it's not a big issue. So, m is equal to 600. Later g value you can take a 10. Let us take a g value 10 so that our calculation will become easier. And h is given 25. Yes, plus half into 600 into v square, that is 50 into 50, this will become fine. And here time is 1 minute, that is 60 seconds. Now let us take a 600 as a common, children. From this it is 600. If you can take common, 10 into 25, this is going to be 250 plus, children, here 2 ones are 225 it is. Okay, now so 25 5s are how much it is? So it will be 1250 by it is 60. 60 ones are 60 10s are. So 250 into 1250, how much, children? It is going to be 1500. Okay, so 1500 into 10, this is going to be 15,000. 15,000 watt. 15,000 watt. This can be written as 15 kilowatt. So children, this is what actually answer is. Children, in the place of G, I mean, we have taken 10, right? If you can take 9.8, here you get approximately 14.9. So it's not a big task. It's not a big problem. Am I clear? So this is what actually problem which is going to attach for law of conservation of energy. So children, if you can write this completely, you are going to get 8 marks. Children, in the next class, we will be discussing one more 8 marks question, that is mostly about collisions. I mean, what is a collision? What are the types of collisions? And how can we find the final velocities obtained, okay, after collision, especially in perfectly elastic head-on collisions. Okay children, thank you so much. All the very best.